In this video, we're going to learn how to evaluate logarithmic functions by using the definition. So let's write down the definition and then we'll do examples. So if you have, here's the definition. If you have log base a of x is equal to y, then we say that this is equivalent to, say, a to the power y is equal to x. So that's the way we can translate a logarithmic expression into exponential, and similarly an exponential into logarithmic. So this is the very important definition you want to remember when you're evaluating logarithmic functions. So let's take a look at our first example. So using the definition, we're going to evaluate this, meaning we'll simplify it. So evaluate log base 36 of 6. What is it equal to? Well, you can say, okay, let's call it equal to x. Anything. You can call it equal to a question mark whatsoever. So I'm going to call it equal to x, and then using the definition, I'm going to rewrite this as an exponential form. So I can say my base is 36. So 36 to the power x is equal to 6. So that will be the equivalent exponential form. Now you sort of want to think of 36 to what power will give us 6? Well, the power has to be a fraction, because the only way we can get 36 to the power to give us 6, it has to be a fraction. So you can think of x is equal to 1/2, because 1/2 would be sort of like a square root. So you can say, if I do square root of 36, well, that gives me 6. So that means x must be 1/2. So you can do sort of guess and check to kind of come up with these results, or just rewriting it in exponential form. Let's try another example. So here's another one. For this one, we want to know log base 4 of square root of 2. What is that equal to? Well, let's call it equal to x. And then we write this in exponential form. So 4 to the what power gives us a square root of 2. So instead of guessing, we'll try to come up with the value for x algebraically. So I'm just going to go ahead and try to rewrite as much as I can. So on the right side, I can write this is 2 to the 1/2 power. And on the left side, 4, I can write it as a base 2. So that will be 2 to the 2, and we still have x as an exponent. So that's 2 to the 2x. Well, now, because both sides have base 2, I can kind of say that, okay, in order for this equation to be true, their exponents must be equal. So we know 2x has to equal 1/2, because those are the exponents on both sides. And then we go ahead and solve for x by dividing it by 2 on both sides. So x is equal to 1/4. So that will be our result for this one. Now let's try the one on the bottom. So here we want to know what is log base 5 of 0.2. Well, because we're not using a calculator, I'm going to rewrite 0.2 as a fraction. So we can first rewrite. So this is same as log base 5 of, so 0.2 can be written as 2/10, because that's 0.2. And then I can simplify 2/10. So we have log base 5 of 1/5. And now I can say, okay, let this equal to x. And then we rewrite it as an exponential. So we have 5 to the x is equal to 1/5. And then by doing more algebraic work, we can say, okay, let's rewrite the right-hand side. So 1/2 can be written as 5 to the -1. And on the left side, we still have 5 to the x. So in order for this equation to be true, the exponents must be equal. So we have x is equal to -1. So there you have the value for x. Now let's do another one. So I have another example where you have the equation format, but you still want to use the definition to kind of solve for the missing variable. So we're missing the base in this equation. So we can use the definition. So we have x to the second power is equal to 25. So now you sort of want to guess what x is. we can tell x is 5, but if you want to solve it algebraically, you can go ahead and take the square root on both sides, so you get x is equal to 5. Now keep in mind, because the base of logarithm is always positive, we want to ignore the negative 5 part, because that's the value we get when we square root both sides. So only take the positive x value, which would be 5 in this case. Now let's do another one. So now let's take a look at this example. So again, we rewrite as exponential form. So we have 3 to the negative 2 is equal to x. Well, here we can just kind of use the laws of exponent to simplify. So we know 3 to the negative 2, that's 1 over 3 square. So we have x is equal to that, and 1 over 3, we know that's just simply 1 over 9 is equal to x. So that's the result we get for x as we convert it into exponential form. And the last example we're going to do is, we want to find what is base x of 8 that is equal to 3/2. So again, rewrite as exponential form. So we have the base x to the 3/2 power is equal to 8. Now here again, you can use guess and check to come up with what is x equal to, or you can simply do it algebraically. So I'm going to go ahead and do it algebraically. So let's go ahead and get rid of that exponent 3/2 by raising it to its reciprocal, which is 2/3. So we do it on both sides, 2/3. So what that means is we have now x is equal to 8 to the 2/3, and we can do better than that. 8 to the 2/3 is a really nice number, which can simply be written as cube root of 8 square, and that means x is equal to cube root of 8, which is 2, and you square that, that is equal to 4. So in this case, x is 4. Okay, so that's it for today.